Good morning. The topic for today is multiple access technique, frequency division, multiple access. So the radio spectrum is shared by the mobile user simultaneously. The sharing may be based on frequency, time, and code. The wireless telephone applies duplexing technique where talking and listening is enabled at a time. For example, frequency division duplexing offers a band of frequencies for every user. Introduction. The simplex channel consists of a forward and reverse channel, and hence each duplexer channel consists of one simplex channel. The forward and reverse channel are separated with a frequency band in the entire system. So there are three types of system: simplex channel, simplex communication, half duplay, full duplay. In simplex channel, it is one-way communication. Half duplay, it is two-way communication, but only one channel is there. And full duplay, two-way communication, two channels are there. So in FDMA, one user is given a forward channel, a reverse channel. On the other hand, the time division multiplexing, known as TDD, make use of time instead of frequency to have the same forward and reverse channel. Both FDD and TDD have their own advantages and disadvantages. The multiplexer schemes with any one of the technique are used for wireless communication. So these are the following techniques, different multiple access techniques available. The important multiple access schemes are time division multiplexing, code division multiple access, frequency division multiple access, and space division multiple access. So in wireless environment, individual users are allocated individual channels. The channels of frequency band is unique for each user subscriber. The entire allowed radio spectrum is divided into many slices of frequency band, and each band or channel is allocated to each user. In conventional telephonic system, bidirectional communication is possible simultaneously, and it is essential for cellular communication also. Such a simultaneous talk and listen facility is known as duplexing. Under frequency division multiplexing, duplexing is done using frequency, and hence it is termed as frequency division duplexing. In FDD, the duplex channel contains duplex simplex channel, namely forward and reverse channel. So the forward and the reverse channel is separated by a frequency separation. The forward frequency band provides radio traffic from the base station BTS to the mobile unit, whereas the reverse frequency radio band provides radio traffic from mobile unit to base station. A duplexer device is kept in mobile unit and base station for enabling simultaneous conversation. Multiple access technique. In figure 2, the principle of FDMA multiplexing scheme is shown where the entire bandwidth is divided in frequency slices and assigned to each user. So in FDMA, the entire bandwidth is not available to user, only a part of the bandwidth is available to the user. FDMA requires proper filtering at the receiver side to avoid adjacent channel interference. So in FDMA, the filter should have sharp cutoff frequencies, otherwise one band will merge into the other and result in adjacent channel interference. In FDMA scheme, if a channel is not in use, it will be ideal and it will not be used by some other user. Hence, there is a chance of resource wastage. Frequency division multiple access. FDMA channels can handle one phone circuit at a time. Complexity is less. Narrow bandwidth. If voice channels are assigned in FDMA, the mobile unit and base station transmit simultaneously. Nonlinear effects in FDMA scheme of multiplexing. In this multiplexing scheme, the same antenna at the base station is shared by several radio channels. The power amplifiers are operated near saturation region for getting maximum possible power efficiency, and it is non-linear. Nonlinear effects in FDMA scheme of multiplexing. These nonlinearities cause spreading of signals over the entire frequency domain, resulting in intermodulation frequency generation. Multiple access technique. Nonlinear effects in FDMA scheme multiplexing. The number of channels that can be simultaneously supported in a FDMA system is given by N is equal to BT minus 2B guard by BC. BT is a total spectrum allocation. B guard is a guard band allocated at the edge of the spectrum. BC is the channel bandwidth. So the number of channels that can be allocated is the total bandwidth minus twice the guard band divided by the channel capacity of individual band. So we come to the end of this section. So first generation mobile communication uses analog signals. So when analog signals are used, we can go for frequency division multiple access. So where the entire bandwidth is not allocated, only a part of the bandwidth is allocated. Each user is allocated one forward channel and one reverse channel. The channel will be allocated for the duration of the call. As long as the call is in progress, the channel will be allocated to the user. Only when the call is cut or call ends, the channel will be dislocated from the user. So the user can use the channel as long as the call is on. And as long as one call is on, that channel cannot be allocated to another user. So these are the features of FDMA. So we require sharp cutoff frequency filters, otherwise it will result in adjacent channel interference. Thank you.